So this diagram here shows how this MPPT solar charge controller system been set up. You have the solar panels connected in series to increase the input the DC voltage. If you have enough capacity on the MPPT solar charge controller, you may add another string here, so to increase the input current as well. And the panel in series is limited by the maximum voltage you could have at input side. The output of MPPT solar charge controller is going to be connected to the battery port through the battery output. This battery could be lead acid, could be all different kind of sealed, or this traditional regular lead acid, or this lithium iron phosphate battery, or LFP battery. The MPPT solar has to be set up according to the type of battery they are using, and it's also affecting the current capacity because they have to make sure not to overcharge that battery. They modulate the current capacities based on the electronic components inside the MPPT solar charge controller, which is a semiconductor. Semiconductor, when they go for high current, they kind of overheat. So that's why we say this MPPT solar charge controller, the current capacity is limited because the current has to be controlled by the electronic devices, NP junction, PN junction inside. And another why they have to control the working point is how its name suggests, the maximum power point tracking. Why they need to track that? As you can see, when the clouds moving over cover one of the panel or the shading on one of the panel, the solar irradiance condition will change. So if you find from manufacturers IV curve, here is a current, this line here, and then voltage, this line. The left side here means in different solar irradiance condition, from 200 watts per square meter to 1000 watts per square meter here, that current change quite a lot. And the MPPT solar charge controller has to kind of modulate according to the irradiance condition. And another they have to change is that based on the solar, this panel, this cell temperature, 65 degree, it will be this line, and 5 degree would be that line. So over at a high temperature condition, the voltage will drop. So that maximum point will also has to be changed. So this is solar charge controller, they modulate change constantly, and they rely on the electronic devices inside to sense modulate that. And over a high current going through is definitely going to overburden that electronic components, causing overheat, because it has to flow through semiconductors, not like a copper to copper contact. Like you can imagine, for a house power supply, to make sure all the appliances are working properly for that much power, say like 100 amps to the house, you don't rely on this semiconductors to modulate the power. You rely on mechanical contact switch to give you that current you need. And then this current, say maximum they can make it probably is just like a 100 amps, and that's output side. 100 amp is actually output side. Too high current, they just don't make that. Even 100 amp, normally it would be referring to the maximum on like it's not constantly 100 amps flowing through. It's a maximum condition that you get 100 amps. But normally, if you try to run 100 amps constantly through it, it definitely causing lots of overheat for the equipment. So that's why we say the whole system set up our power limit is limited by the MPPT solar charge controller. First, there is the electrical component. The second is that they have to modulate according to the battery discharging characteristic, not to overcharge that, not to have too much current going through. So it's lots of things being built inside to limit the power capacity to control that. That's why we feel like the MPPT solar charge controller system is quite limited. And also another point here we want to point out is that when the solar panel manufacturer and try to overcome the shading factors on the panels. If you connect them with too many solar panels in series, they say one panel be covered by the cloud, it's been shaded, and not affecting the whole here because the current has to go from bottom to the top all the way. So they say, okay, I can build an optimizer inside, and that optimizer works in certain temperature this range. And then if you have the electronic components exposed in the weather from minus 40 degrees to positive to 65 degrees, with that temperature range, electronic components, their behavior will change too. So that's why we end up with quite a high maintenance cost, because of the panel is installed outdoor weather condition, not like an MPPT solar charge controller. You can put them indoor, have proper temperature humidity control. Another thing is like for some of the manufacturing, they build in micro inverter. Say you have a string PV system, and the voltage can be really high, 1,500 VDC. And they build this micro inverter inside, but it's different, may not be used in the MPPT solar charge controller system. They say, okay, because this one panel put lots of them in series can be affected by other panels malfunction. So they try to build a micro inverter. Micro inverter is built behind each every panel. So small this electronic devices, they change DC to AC directly to power the AC load. And as you can see, this micro inverter is also working in the outdoor weather condition. Could be minus 40 degrees, could be positive 65 Celsius degree, and their behavior changes. So this is another reason it end up a high maintenance cost for those kind of system as well. That's why we say, okay, this MPPT solar charge controller system, we make it 100 amps, and that's actually refer to the output conditions maximum 48 DC. If you have 12 DC, 12 volt, the capacity is very, very limited. So this is the reason why we cannot satisfy this kind of system to power the high capacity appliances. So we know that we are not satisfied with the capacity from MPPT solar charge controller alone to power a house. And that's why we come out with this idea to have the solar charge maximizing controller to be included in the system. And that whole system, we call them a solar charge maximizing controller system. It includes the original this MPPT solar charge controller system still charging from the solar panel to the battery, but this battery here, what we are using is limited to the LFP only. We need to have that battery has its own battery management system. Currently, we cannot use net acid-based battery because it has no battery management system. And we need the battery to it has its own this voltage limit control, current limit control, and this LFP battery always have that built inside. It's called a lithium iron phosphate battery. F stands for Fe, is the iron. So LFP battery, that's what we use in the solar charge maximizing controller system. And the most important is this system has a mechanical switch built inside to conduct the high current. On top of the existing this series connected solar panels, in this system you can have up to total 12 of this panel, 120 amps panels connected in parallel to be connected to the solar charge maximizing controller, and that controller has a mechanical switch built inside to conduct a high current for high current power supply to the DC node. And that DC node is not just limited to the DC-AC inverters. That DC load can actually power the PEM cell or AEM cell for the green hydrogen production as well, any kind of a DC load. But for energy storage expansion, we say this is the most efficient way to harvest solar energy from the sun and directly go to the DC load, such as proton this membranes to produce that green hydrogen directly. So your green hydrogen don't need to go through the power for green hydrogen production, don't need to go through all these transformers, grid power supply transmission rules, and this DC to AC, AC to DC, this inverter, converter change, put a lot of this power loss into the system, and this is the most efficient way you got DC power to produce that green hydrogen directly. And the most important point here is that originally this MPPT solar charge controller system would still work in case this mechanical switch is disconnected at a certain voltage setting point. We want this solar charge maximizing controller to be off. We're going to talk them in details in this course at what point it has to be set and what kind of condition to be disconnected, and how to size the system properly to make sure it's not short cycling. It will function very smoothly. And this one here we want to point out is that even when that is set, it's disconnected due to the setting point, say the certain this solar radiance condition, you don't have to have that 1,000 watts per square meter, and the capacity from all other panels is still available for the MPPT solar charge controller and can still power the load directly. So this is the solar charge maximizing controller system and the principle how it works in the rough introduction. But in details, we are going to explain them in the course content. And I hope you see you there. Hope you see you there soon. Thank you.